I'm Dan Myers with Pepper Construction. I'm the project executive of our Heart and Vascular Institute project here at the Carle Foundation Hospital in Urbana, Illinois. And in each patient room, there are a number of pipes for electrical, data, phone, nurse call systems, plumbing systems for dialysis rooms, medical gas, all crammed into one wall, all at the head of the patient. And to fit all those in, if you went on a trial and error method, you'd crash and fix and crash and fix. Instead, we've drawn it three-dimensionally in the computer first, and then we're building them off-site in 10-foot wide sections of wall, about 6 foot tall, that are all built the same way in a controlled shop environment. It helps with having less men and less material on the job site at one time, and that helps keep the job site cleaner, helps keep our schedule going faster. And as you can see behind me, we don't have the building completely enclosed yet, and yet we're already building head walls, the thing that will take the longest to complete inside the patient rooms.
My name is Todd Watson, and I'm a project manager for Pepper Construction. Our role as the construction manager is to bridge the communication requirements between the owner who wants a functional building, the architect who has a design intent, and the tradespeople who have specific requirements and must follow the codes in order to make everything operate. So for the head wall specifically, we had an initial layout from the design team that was probably put together a year and a half ago between the users of the hospital and the design team. If we were to strip this drywall off, you would see an intricate network of conduits for electrical, data, as well as med gas piping and plumbing piping that allows all of these devices to work as intended by the design team and as requested by the owner. Without the use of BIM, getting everything to fit inside of this wall accurately would be next to impossible. So to start the process, the sheet metal template is stamped in the shop to have the precise openings for all the electrical and med gas outlets. We frame up the partition and apply the sheet metal template. Once that's complete, they set it into the racks and they start roughing in the electrical and med gas piping. They assemble the valves, the fittings, the 90-degree bends, etc. Once that's completed, they bundle that package together and put it on a rack for delivery to the job site. All of the assemblies that leave this prefab shop are labeled and identified for the particular location that they're going to be installed. So once the structure allows, we call up the warehouse and we request a delivery of the head walls. And they load them up on the truck, send them over. They get transferred off of the truck onto the elevator and up into each patient room. Then the carpenters come through and set them in place. While the installation of the head wall panels goes very fast, there's a significant amount of work that has to happen ahead of time. The center line of each bed is laid out in the room. Additionally, we have to compensate for the variance and tolerance in the floor construction and build the knee wall elevation to compensate for that. That is built off of a benchmark, which allows the head walls all to be set at a consistent elevation throughout the job.
So instead of waiting until the structure is ready and then building everything in place, we're getting a jump on it off-site. And it's a controlled condition in a warehouse off-site, so everything's dry and everybody gets a chance to basically build it on the table. In a traditional sense, you'd have a guy going from room to room to room, dragging his tools. Again, a cleaner job site makes for a safer job site. He's not leaving things behind in each room, and everything is controlled out in that off-site facility. So there's speed of schedule. Speed usually translates to cost, and you have the quality and the control of having it done in almost a manufacturing type environment instead of a field environment.
The tradesman in the field is literally taking these pieces from a drawing and putting them together with very, very minimal cutting or changing or having to decide how to route a pipe. It's all laid out, it's very simple, and it's very efficient.
To sum it up, using BIM on the project has really provided a lot of value to the client in a matter of time, cost savings, quality control, so it really pays off. Right now we're standing in one of the almost finished ICU patient rooms, and our standard detail here for all of the patient rooms is a millwork head wall panel with all of the medical treatment devices roughed into the wall and behind. and this is where we focused the major effort of our prefabrication operation. First we did a mock-up with just plywood, and then we did a mock-up with some MDF board, and then we mocked one up that was the final laminated finished product. And we learned a few things about how this would all come together. Any variation tolerance in the panel itself would show up between panels. And so we did perfect our detail with a tongue and groove at each panel so that once you lock them in, that really prevents them from pushing in and out. The quality of the work is improved in this process because you have almost manufacturing style control of the work. And since the millwork headwall panels were fabricated off of the same 3D source CAD file, that meant that where the holes were pre-cut, they matched up exactly with where the headwall devices were located. But then it really shows up when you get out in the field and you take the millwork panels from a separate vendor and you apply his panels on top of what has been put in the wall. And you can see that by now, if you had to move one of these even a half of an inch, you would be cutting the wall open, moving pipes. So when it comes time to install them, everything lines up smoothly, and it goes very swiftly actually, because you don't have to stop and fix and stop and fix. The install of this goes much faster, it's much more precise, and takes less man hours to get this done than the old-fashioned way. By noon the first day, we had probably 10 head walls set, and that is something that would be easily a couple of weeks of wall rough-in in the field, so that had all been taken care of, and that helps us accelerate the schedule inside. There's about 2 months of rough-in time that we essentially displaced and did early, so that, for all intents and purposes, shortens that construction schedule by about 2 months.